Volume of prisms and cylinders. Volume is the amount of space that is occupied by a three-dimensional figure. It also references the number of cubic units needed to fill a 3D figure, such as layering, or you could think of if you're trying to fill a cup with water, you're filling it with cubic units of measurement. So when we find the solution to volume problems, we label our solutions as units to the third power, or units cubed, or we write out cubic units. When calculating the volume of prisms and cylinders, you multiply the area of the base and the height of the solid together, or V for volume is equal to capital B times H, where capital B represents the area of the base. And the area formulas that we'll be working with are the area of a rectangle, which is length times width, or base times height. Note that this height that's down here is not the same as this height of the solid up here. So it'll be helpful to label different measurements in the diagram using subscripts when needed. Similarly with a triangle, if you have a triangular prism, you would calculate the area of the triangular base first, which is 1/2 base times height, and then you would multiply the area of this base times the height of the solid. And then for a circle, or if you have a cylinder, you have pi times the radius squared is the area of the circular base. So really for a cylinder, if you wanted to, you could simplify that volume equation to be pi r squared times the height of the cylinder, because they will always be the same. So this is r and this is h. So you can write the volume again of a cylinder as pi r squared times h. And if you wanted to, because with a rectangular prism, its area is length times width, you could take length times width and replace the capital B here to write the formula as length times width times height, where you have the length here, width here, and height here. Find the volume of the rectangular prism. Well, we know that in order to find the volume of any prism, we can use the formula V is equal to capital B times H, where capital B stands for the area of the base. And since we have a rectangular prism, a rectangle is our base. And the area of a rectangle is length times width. So we can replace capital B with length times width and then keep height at the end. And now let's substitute our values in. The length is 5 1/2. Our width is 2 1/4. And our height is 8 2/3. Okay, so now we have these three mixed numbers. And in order to multiply them, we have to convert them into improper fractions. So 5 1/2 converts to 11/2 because 5 times 2 is 10 and 1 more is 11. 2 1/4 converts to 9/4 because 2 times 4 is 8 and 1 more is 9. And then 8 2/3 converts to 26/3 because 8 times 3 is 24 and 2 more is 26. All right, so now we can multiply these together. But before doing so, I see some common factors that we can cancel out here. I see a 3 and I see a 9. Well, 3 divided by 3 is 1, and 9 divided by 3 is 3. I also see some even numbers. So this 4 can be divided into 26. Both of them can be divided by 2, I should say. 4 divided by 2 is 2, and 26 divided by 2 is 13. And now we can multiply these revised numbers together to get our solution. So we're going to have 11 times 3 times 13, and we're going to have 2 times 2 times 1. So if we multiply them together, we have 11 times 3, which is 33, times 13, which is 429. And in the denominator, we have 2 times 2 times 1, which is 4. So we have 429 fourths. And if we convert this back into a mixed number, it would be 100, and then 4 cannot be divided into 2, so I'm going to put a 0 in that tens place. And then 4 can divide into 29 7 times. That'll give me 28 with 1 left over. So we have 107 1/4 cubic meters for the volume of this rectangular prism. And as we can see on this slide, we do still get 429 over 4, which converts to 107 1/4 cubic meters as our solution. Find the volume of the cylinder. Use 3 14/100 as the value of pi. Well, we know that the volume of a cylinder or prism generally follows the pattern of area of the base times the height. Well, the area of the base in a cylinder is always a circle. So the area of a circle is always pi times the radius squared. And we still have the height that we're dropping down. So now we have these values in our diagram, and let's fill them in. So we have 3 14/100 that the question tells us to use for pi. The radius is 9, and we're going to square that, and the height is 10. So then we're going to have 3 14/100 times 81 times 10, and 3 14/100. We can multiply 81 and 10 together to get an easier number to work with, which is 810. And we can do that because multiplication is also commutative, like you can multiply in any order you'd like. And now if we put these in the calculator, 3 14/100 times 810, we get 2,543 4/10 cubic yards. And here we see the solution to this example problem, and it does match what we had calculated for the volume, which is 2,543 4/10 cubic yards.